Hello everybody. In this video, we'll be looking at the quotient rule, or the fraction rule. So if one has a function like 3x plus 1 over x squared minus 9, and they want the derivative of this, I would say let's use the fraction rule. There are other ways, but I see a fraction, why not use the fraction rule, better known as the quotient rule. So what is the quotient rule? Well, please look it up in your textbook. It says if you have a function u or a function v, the derivative of this, and we'll just put it up over here so we have it for future reference. If you have a fraction u over v and you want its derivative, you would look it up. It is u prime times v minus u times v prime all over v squared. There are many ways to say it. There's cool little jingles out there. I just need a nice little formula over there so I can utilize it. And that's what I'm going to do. So when I see something that's a fraction, first thing I have to know, the numerator is u, my function u of x. My denominator is v, my function v of x. And now I'm just going to chuck the components in there. To me, the quotient rule is really just 1, 2, 3, 4, 5 pieces I plug in. So what do you mean by that? What I mean by that is when I take the derivative, f prime, or depending on your professor, df dx, which remember what this says, the derivative of the function f with respect to the variable x. Again, better known as f prime. So how would I take the derivative of a fraction? I'd look at that rule. I'd say I need u prime in a box. I like to box everything. Makes everything very nice and simple for me. V minus u v prime. And yes, I'm just writing the formula down one more time. All over the bottom, and this is critical. The bottom squared. Please notice it says v squared there. So this would be v, and I'm squaring it when I plug it into that box. So now, just dump in what you know. The cool thing, there are 1, 2, 3, 4, 5 boxes. Well, there's a lot of cool things. It's calculus. But the really cool thing is 3 out of the 5 boxes are free. U is the top expression, the top function, so 3x plus 1. There it is. V is the bottom function, x squared minus 9, x squared minus 9. And look at that, your 3/5 already done, already plugged in. Now, all we have to do is actually take the derivative. U prime, that's why I go slow. There's u. So u prime, well, the derivative of a linear is the slope, which is 3. The derivative of 3x is 3. The derivative of 1 is 0. Cool. I need v prime. There's v. I need v prime. So the derivative of x squared, we all know that, good old power rule, is 2x to the first. Right? Bring the power down, subtract 1. Derivative of 9, it's 0. And there you have it. The derivative via the quotient rule. Should be fast, straightforward, no problems with these. So what do you do now? Well, it depends on your professor. If your professor wants you to evaluate the derivative by plugging in a number, go ahead, plug in a number, be careful. If the professor wants you to simplify, well, let's look at that. F prime, let's simplify. Well, in this case, simplify, I'm going to distribute the 3, because that's good algebra, and then I'm going to distribute the 2x. Really, calculus is nothing but algebra. I'm going to constantly repeat that. Good algebra skills. 3 times x squared is 3x squared. I'm going to distribute right now. 3 times x squared, 3x squared. 3 times 9 is 27. That's distributing right there. Back end, the minus. And whenever you distribute, you got to be careful of that minus. You either got to distribute that or distribute it at the end. I like to do it at the end. I like to multiply this out, then distribute the negative. I want to take my algebra time. All right, 2x is going to distribute in. 2x times 3x. Remember, when you multiply like bases, you add the exponents. So we get 6x squared. So when you multiply like bases, you add the exponents. That's where the x squared is coming from. 2x times 1 is 2x. So yes, simplifying is really all it comes down to is how good did you do in your algebra classes from 8th, 9th, 10th, whatever grade you took your algebra classes. I'm going to give you a little hint. Do not simplify the bottom. Don't FOIL out the bottom. It's not worth your time, really. If you're doing a multiple choice test and you don't see that and they multiply it out, please FOIL that out. I would keep it like that for what I know in applications, what I want to do with it. We're almost done with this. Now, distribute the negative and collect like terms. So if you notice, you have a negative 6x squared, 3x squared. That's a negative 3x squared. Because, right, 3 minus 6. You have an x term, be careful, minus 2x. And then minus 27. And that's all over. Once again, to me, the denominator's beautiful. In future videos, you're going to want to know where the derivative is invalid, where the derivative does not exist. And seeing the denominator like that really pops out the numbers. I can already tell you 3 is a problem point, because when I plug in 3, I get a 0 in the denominator, and you never want that. Also, when you plug in a negative 3, you get a 0 at the bottom. Look how quickly I was able to ascertain the problem points for my derivative. The numerator, I got some work to do if I want to figure out where the numerator is equal to 0. We'll think about why we care about that later in later videos. Right now, this video is all about, here's a function, let's find its derivative. Excellent. So, let's do another example. They can get really, really nasty. All right, guys? You just got to take your time through these, and depending on your professor, simplify or not. So let's have another fraction. Let's get a little nastier. Let's say we have the square root of 8x minus 1 all over parentheses x to the 4th plus 3x squared to the 7th. And there is my fraction again. And yes, that one more time would be the quotient rule. I'm going to utilize that. How do I know which one to use? Because there's a lot going on, right? You have a parentheses power, that means chain rule. You have a radical, doesn't that mean a power 2, Dr. McCullum? It does mean. So what does that mean? You got to think about what is the last operation you would do. That would, to me, is the first time I take the derivative. What rule really signifies my derivative? The last operation is the division. Why? Because when you plug in 2, you're going to get the parentheses, get the power. When you plug in 2, you're going to get this and take the square root. The last thing a computer's going to do is divide the 2 in the end when you plug in 2, whatever number you want to plug in. So that's why I know the quotient rule really rings true here. So how does one do the quotient rule? Well, let's pause. First of all, I'm going to do a rewrite. Whenever I see a radical, I do a rewrite. So a square root is a 1/2 power, all right? That's very important to me. As soon as I see a radical and I need a derivative, I go back to my exponent rules and I rewrite it as a power. Now I got my u and v. Remember, your u is always the top. Your v is always your bottom, the whole bottom, everything. The u is everything, everything in the top. Now, perfect time to hit that pause button. I guess not yet, hold on. Try out the problem. You got it here, try to do your best. Click the pause, try it out, and then click play again and see how you do. Why not be interactive with me? Why not be engaging with me? Let's try it out, you know. And there was our pause. Now we can take the derivative via the quotient rule. So how does one do it? I'm just going to write it down. Now I know u prime could be complicated, so I'm going to leave myself some good space for u prime. V is just a rewrite, so v is small. Minus u, all right, so it's pretty small. V prime could be pretty big. I usually leave a lot of space for the derivatives. Bottom, well, the bottom is just the bottom squared, so I can dump. If you want to already place it in correctly, you can, if you write correctly, you can write it in, and just be careful. That's v. I still got to square it. Too many times people forget to add the square. I mean, there's the formula. It's v squared. V happens to be very nasty. All right, and we're not doing a simple problem here. I want to make sure we take our time. We have not learned exponentials, logs, and trigs yet. If you're wondering, well, how come you don't see those yet? We're not there yet. Future videos will have e's, logs, and trigs. Right now, we have polynomials, rational functions, radicals to play with. Good enough. So we have this expression. We dump it in because that's v. The whole denominator is v. So we plug it in, and we have that. Cool. Don't forget your square. Often a mistake. All right, what are we doing now? My formula says put v there. All right, so v once again goes here. X to the 4th plus 3x squared. Should have left myself more room. Just said we should leave room, and I did not. So there's my v, right? There's my formula, right? U prime V. Then it's U. There's U up top. In its exponent form. I want to put in the exponent form. Because honestly, the reason why I like this problem right here, it's got pretty much our top 5 basic rules right in here. Because every single time now, I'm going to use the chain rule. Because I have a parentheses power. I really want to beat that home because I want to get you guys used to seeing when we work with parentheses powers, a chain rule will come into play, will come into effect. All right, so I need U prime here. So there it is. So let's take our time. It's bring the power down. The power is 1/2 because it was a square root. Leave the inside alone. Not going to lie to you. Every time I hear leave it alone, I keep thinking of MC Hammer, can't touch this. Da, 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 da. Because I'm leaving it alone. I'm not touching it. Subtract 1 from the exponent. So I bring the power down, leave it alone, subtract 1 from the exponent. Know your algebra. 1/2 minus 1 is a -1/2. Have your calculator handy if you're not good with fractions. Now we got to multiply, because that's the chain rule, multiply by the derivative of the inside expression. The derivative of 8x minus 1 is 8. So again, just to clean this up in discussions, whatever's in here, the derivative has to be dropped right there. Or placed right there. Excellent. On to V prime. Again, over and over, the same rule. Bring the power down. Leave the inside alone. Can't touch this, all right? Leave that inside alone. Subtract 1 from the exponent. Power down, leave it alone, subtract 1 from the exponent. Now, need more space. Now I need to take the derivative of the inside expression, which would be 4x cubed plus 6x to the first. So again, via chain rule, the derivative of this goes here, via the chain rule. Again, if you need a review on the chain rule, I'd go look at that video. To be honest, the question in this section is not about who can now clean it up with some nasty algebra. It's about, can you attack any fraction, no matter how nasty it is, can you really utilize the quotient rule for all the power it has? This is a beautiful derivative. What are we going to do with it? Look at future videos to see what we utilize the derivative for. Really right now we're working on the frame, working on the basic building blocks. How do I take the derivative of product? How do I take the derivative of chain rule? How do I take the derivative with a quotient? Once we get those in place, we can look at the applications. Thank you guys so much for this.